In our previous lectures, we've discussed what Android is, the Android Development Toolkit, the Android Software Development Kit, and other ingredients that are required to make an Android app, a PC or a Mac, the Eclipse IDE, and the Java programming language. In this discussion, we're going to start to look at the programming concepts used in an Android program, and we're going to test out our Android development environment, see what happens when we get an Android program that's up and running, and we'll also create an AVD, or an Android virtual device. So we're picking up on our last few lectures where we talked about what Android is and how to get it installed. Now we're actually going to roll up our sleeves and start writing an app. So Eclipse, an integrated development environment, and what that means is we can write our program, compile our program, run our program, and test and debug our program. You might be taking this course as a hobby, in which case you'll use Eclipse a little bit. On the other hand, you might take this course and decide this is something you really enjoy and something you'd like to do more of. If that's the case, you'll probably use Eclipse quite a bit, even outside this course. So, as we're going through this course, a lot of times I'm going to use some shortcuts that are native to Eclipse, shortcuts that will help you do more things in less time with Eclipse. As we do that, I'll say what I'm doing, and hopefully that will help you to use those as well and maybe commit those to memory and make better use of them yourself. So first of all, we have this concept called an activity in Android programming, a single focused thing that the user can do. Many times, if you're using an app, an activity might be a single screen and the behavior behind that screen. In other words, when you click a button, what happens? When you click a button on a screen, what happens? It's the activity that determines what behavior will occur when you click that button. It's the activity that determines what behavior will occur when you click that button. Now, an activity is that logic. It's the thinking behind what happens during a button click. It's not the same as a layout, but it's very closely associated with a layout. So a layout is the look and feel of a screen. It's where the buttons go, where the labels go, what the title is. The layout is separated from the activity, but then they're joined together. So it's a separate file. The layout is written in XML. The activity is written in Java. It's a separate file, but they're very, very closely related to each other. The advantage is, to be honest, most programmers aren't really good at graphical design. So the advantage of having these separate is that you can have the programmer work on the activity and decide what happens when you do a button click. What's going to happen when you do a button click? Meanwhile, you could have a graphical developer or a user interface expert work on the screens separately. And as long as you agree what the buttons are going to be called, what the text fields are going to be called, what the images are going to be called, then you can have two different people or two different groups of people work on this application and then glue it together at compile time. So activity is the programming code. Layout is the physical layout with the buttons and the text boxes and text entry fields and things like that. We also have a concept that's a bit more vague, and this is something that we're going to talk more about this semester, but to be honest, at this early stage, won't make a whole lot of sense, and that is an intent. So an intent is an abstract description of an operation to be performed. That's an incredibly vague definition, an abstract description of an operation to be performed. Here's the best way I can describe it. Many times if you're on an application, for example, if you take a picture with an Android phone, a lot of times it will open up a gallery view. But sometimes it won't directly open a gallery view. It will say to you, how do you want to view this picture? Do you want to open a gallery? Or do you want to use some other software that's used for displaying pictures? Similarly, you might be in an application and you click on a link that should open a browser. Okay? Sometimes it will go straight to a browser. Other times it will give you an option. It will say, which do you want to use? Do you want to use Chrome, which might be installed on the Android device, or do you want to use the built-in browser? So what's happening in that case is the program is registering this intent. It says, I want to open this link in a browser. It's not saying which browser. It's either letting the Android operating system pick the browser, or it's giving that decision to the user. So that's what an intent is. It just says an intent is just an abstract thought of, I want to open this web page in a browser, but I'm not going to say which browser. I'm just going to say, I want to open this page in a browser, and I'm going to let either the user or the operating system pick the best browser that's going to meet those needs. So, 3 things. We have the activity, which is the programming logic behind a button press. We have the layout, which is the physical look and feel of a screen. And then we have the intent, which is, I want to send an email, I want to show a picture, I want to open this link in a browser. Once again, the class that you're in assumes little or no programming experience. So think about that. What's our goal? Our goal is to make an app as quickly as we can with as little programming as we can. Intents are very central to this because we don't want to rewrite a browser, do we? We don't want to rewrite an image viewer if one already exists, do we? We don't want to rewrite an email program if one already exists, do we? So what we're going to do in this class is we're going to focus on using intents to call software modules that already exist so that we don't have to rewrite them from scratch. So that's going to be a big focus of this class. I said it might seem a little bit vague right now, but this intent is very much key to making a very functional program without doing a lot of coding. And that's good, because the less code we have, the less work we have to do to write the code, the less work we have to do to test the code, and the less work we have to do to maintain the code. So keeping that footprint small and reusing things that have already been created is very, very important. Okay. Those last few words were very Android specific. Activity, layout, and intent. Those are Android specific terms. What we're going to talk about now are more general terms, general to the Java programming language. So these terms might seem, again, a little bit abstract, but we can really talk about them and relate them to parts of the English language. Think about this. What is a noun? A noun is a person, a place, or a thing. What is an adjective? An adjective describes a noun. A noun could be a dog. An adjective could be a blue dog, or a white dog, or a yellow dog. Okay? An adjective could be a dog, or a noun could be a dog. An adjective could be a short dog, or a tall dog, or a heavy dog, or a light dog. So think of noun and adjective. Another part of the English language is a verb. A dog runs. A dog stops. A dog begs. These are things that a dog can do. So think about that. Noun, adjective, verb. We can align those up with these terms in programming. A class is a noun. An attribute is an adjective that describes the class. A method are verbs that the class can do. Okay, so I have a separate video that I'll post for you, an actual recorded video that I'll post for you that goes into these in a little bit more depth, but that's the idea. A class is kind of like a template. So a dog, what's a dog? We have the concept of a dog, okay? But then we can also have an object. An object is a specific dog. Okay, so a class is just the concept of a dog. An object is a specific dog. I'm recording this video at home, and periodically you might hear my dog behind me. I put her in a room because she was being a little bit noisy. But my dog is a dog. She has an age, she has a weight, she has a color, she runs, she walks, she barks, she chases. Okay? So when we look at an object is not just a dog, but a dog who has values for attributes. Class defines what the attributes are. Age, weight, name. Okay? Age, weight, name. Attributes, a class defines what the attributes are. It does not give them values. We can create an object from a class and give those attributes values. Again, if we create an object from a class, we can give those attributes values. My dog, Checkers, she was adopted a year ago, almost a year ago yesterday, as a matter of fact. So we don't know her true age. We think she's about a year and 9 months. So for my dog, Checkers, her name is Checkers. Her age is a year and 9 months. Her weight, probably about 65 pounds. So that's an object. Checkers is an object. Class just defines what the attributes are. Object actually gives them values. Okay. Verb, my dog knows several verbs. She's a very smart dog, and not to put in a plug here, but she was a dog rescued from a pound, and I will tell you she is absolutely one of the smartest and fastest learning dogs I've ever seen. She's absolutely brilliant. She knows sit, she knows lay down, she knows wait, she knows place. So if I'm eating, she has a little carpet that she'll go and sit on that she knows she has to stay there while I'm eating and not beg for food. So these are verbs. Stay, wait, lay down, sit, place. These are all verbs that my dog can do. Okay. Now, at this point, I've been talking for a little while, and it makes perfect sense to me, to be honest with you, but maybe to you, this is the first time you've kind of heard class and objects. And when you're beginning programming, that line between what a class is and what an object is hard to determine. Is this a class or is it an object? It's a bit hard to determine. And that's why I'll point you to something called a VLO, or a video-oriented learning objective. I think I missed the I. I forget what the I stands for, or UCIV is what it's called now, a UC interactive video. I'll point you to one of those where I actually go into several very specific examples of a class versus an object. Be sure and look at that. That should help clear up the last few slides that we went through. Okay. So, object-oriented vocabulary, a lot of this we already talked about. What is an attribute? What is a method? And what is the variable? Okay. An attribute is an adjective, name, weight, age. Method is a verb. A variable is just a way that we store data on the computer, either in temporary memory, which would be RAM. And RAM, once we turn off our computer, we lose temporary memory. It erases. Or in permanent persistent storage, like the SD card. Okay. Remember that our computer knows the language of zeros and ones, and that's all it knows, the language of zeros and ones. We have to tell it how to interpret those zeros and ones. The computer will always turn zeros and ones into a number. But then we have to decide, do we want to read that as a number, or do we want to take that number and put it into a map? Or use a map, in other words, use it as a reference in a map. That map could map numbers to letters. Okay? So we take the zeros and ones, we convert them to a number, a decimal-based number. Then we can take that number and we can reference that on a map, convert that number to a letter. Okay? Or we might take our zeros and ones and convert them to a number. And then that number will represent a color. Okay? Or maybe a part of a color. Or we can take those zeros and ones, convert them to a number. That number might represent a sound. Okay, so the variable means we're allocating space in memory. And we need to give the variable two things to make it a variable. Number one, we need to give it a unique name so that we can recall this variable later. We need a unique name for that. Number two, we need to give the variable a type, which is what I was just talking about. Is it going to be a number, a letter or a series of letters, a color or a series of colors, a sound or a series of sounds? That's what a variable is. A variable has to have a name which is an address, okay, like a unique name. It's an English name, it's letters and numbers. A name and a type. Those are the two things a variable needs to be, a name and a type. Okay? So, methods, remember, are verbs. Methods are verbs. And here what we have is a method signature. Public int add these numbers. This looks like a kind of confusing syntax because we see a lot of letters and a lot of symbols, and it's not all going to make sense right away. We'll need to see this a couple times before it makes sense, but we can go ahead and explain it. A method will have what we call an access modifier, which limits who can call it. In this case, we're making this one public, which means just about anybody can call this method. Okay. Then we're going to give it a return type, which means when the method, remember, method's like a verb. Method is some kind of work we're going to do. When the method is finished, it's going to return this value. Next, we're going to give the method a unique name, and this is something we can make up. It just has to be a unique name so that we can call this method uniquely by its name. Next, we have parameters, and parameters are things that we pass into a method, pieces of information that we pass into a method. In this case, we're passing in a number. Int means a number, an int x and an int y. So we're passing in two numbers to this method, or this verb in other words, and we're getting a number in return. Int is an integer, represents a number. Passing in two numbers to the method. How do we know we're passing them in? Because any incoming parameters are in these parentheses. Passing in two numbers, getting a number back in return. Okay? This is the signature of the method. Signature has to be unique. All of this together is the signature of a method. Then we have to give the method boundaries. The open curly starts the method. The close curly is what finishes the method. So everything between the open and the closed curly is within the boundaries of the method. The method finishes when it hits the closed curly. So what we're doing here is take a look at that x. That's the same as the number that was passed in. Take a look at the y. That's the same as the number that was passed in. We sum these two together, assign them to a new variable called new num, and then return that sum. Okay? And that's what comes back out of the method. So remember the definition of computing. We take data in, we process it, and we put data back out. Okay, input, process, output. So this is our input, this is our process, this is our output. Input, process, output. Let's look a little closer at this line. Remember that I said for a variable we need two things. We need a name, which in this case is new num, and we need a type. Type is int. What we're doing here is we're declaring a variable. We're declaring a variable. Int means it's a number, and a number, which is called an int, means it's going to take 4 bytes in memory. So if you hear gigabyte, megabyte, 4 bytes is a unit of measure. 4 bytes means it's going to have 32 zeros and ones. Okay? So what we're saying is we're allocating 32 zeros and ones in memory, either in our random access memory, the temporary memory, or in our persistent storage. Either way, we're declaring, okay, 32 bytes, I'm sorry, 4 bytes, 32 bits, 32 zeros and ones. And those 32 zeros and ones are going to store the sum of x and y. Okay? So what we have here is a variable name, variable type. Now we want to put something in that variable, and that's what the equal sign is. A big note here, a big footnote. When you see equals, it does not mean a comparison. The equal sign does not mean compare this to this, as if it were mathematics. In programming, equals actually means assignment. What that means is look to the right of the equal sign. do whatever operation you see to the right. Do whatever that tells you to do. Take the result of that operation and store it in this variable. Okay? The equal sign is assignment. It means do what's on the right, take the result of that operation, store it in the variable on the left. Okay? Do what's on the right, perform whatever operation this has, take the result of that operation, store it in the variable on the left. So we see this line is actually pretty involved. We're declaring a brand new variable, and then we're assigning to that variable the sum of x and y, which were passed in. We're assigning to that variable the sum of x and y, which were passed in. So this is it's a kind of goofy syntax if you haven't programmed before, but it's very important to make sure that you understand what's going on here. We have a method. Open curly, close curly defines the boundary of that method. Within the method, we are declaring a variable, and then we're doing some math to the right of the equal sign. We're taking that final response, that final result, and we're storing it in that variable. Okay, so I talked about an int. An int is a whole number. That's one of the more common types of data that we have. It's a whole number up to 2.1 billion, plus or minus. It's any number up to 2.1 billion. If you need a larger number, there's another data type called a long. That can go to a humongous range. Okay. So we also have a few other data types. We have something called a float and a double. Those are floating point numbers. In other words, float and double can have a decimal point. An int cannot have a decimal point. Float and a double can have a decimal point. And then we have Boolean, which is simply a true or false. Those are some of the primitive types. Primitive because they're very close to the zeros and ones which are in memory. If we go up a level, there are some other data types as well. A string is a series of letters and numbers. A text field is where we can prompt the user to enter data. A label is read-only text that the user will see. So these data types for variables can be either a very primitive, a very simple, like a number or a true or a false, or we can map them to more complicated data types like a string, which would be text, any kind of text, a text field, which is where we're prompting the user for information, and a label, which is where we're displaying read-only information to the user. Okay, so we talked about classes and objects. Classes will typically be Pascal case. What does that mean? That means we take words and put them together without spaces, and we uppercase the first letter of each word. If you think of like Radio Shack, that name is Pascal case. In my dark days, I used to work in a Radio Shack back in the 90s. And back then it was two different words, radio and shack. Then about the time the internet came out, they decided to look cool and put both of those words together and take the space out and call it Radio Shack as one word, with uppercase R, uppercase S. So that's Pascal case, okay? We take the spaces out between words, uppercase the first letter. If we have only one word, we uppercase that first letter in the word. So that is the naming convention for classes. For variables and methods, we do something very similar, but it's called camel case. For camel case, the entire first word is lowercase. We take out the spaces between words, and then we uppercase or capitalize the first letter of the second word in every word thereafter. So, classes, Pascal case. Uppercase the first letter of every word, including the first. Variables and attributes and method names, camel case. First word lowercase, all words after that uppercase the first letter. If you look back on our previous example, add these numbers. Do you see how that's camel case? Add is lowercase. These, first letter is capitalized. Number, first letter is capitalized. Class dog, that's Pascal case because the D in dog is uppercase. Okay. A couple of examples here, some variables. We have an integer called time of day. Notice that's camel case. String username. Notice that's camel case. Label, name label. Notice again camel case. We can name variables anything we want. The names have to be unique. We can name variables anything we want as long as the names are unique. A good rule of thumb, make a variable name as descriptive as you can. We don't want a variable named x. That's confusing. It doesn't tell us what it means. We get sloppy when we have variables like x. We like descriptive names like age, color, things like that, horsepower, things that describe what the variable is holding, what data the variable will be holding. Okay. Now, in the Java programming language, this would be illegal. We cannot start a variable name with an asterisk. So that is a name that's a naming convention we're not permitted to use. Okay. Well, this sending a message and accessor methods, these are different methods. This is much easier to look at in an example. So I'll tell you what, we're coming up on the 26.5-minute mark, which is about when I want to save a presentation and post it. So let's hold the accessor methods and sending a message for our next discussion. Let's go ahead and wrap this up. We remember we have 3 words that are specific to Android: activity, layout, and intent. Activity is the logic that happens when you press a button. Layout is the physical look and feel. Intent is an abstract thing you want to do. Show a picture, open an email, show something in a browser. So those 3 words are Android specific. But then for programming, we have some words that are more general. Class defines the attributes, is a template that defines attributes of a noun but doesn't give them value. You can create an object from a class, and in that object you give value to those attributes. So a black 65-pound dog named Checkers. Okay. Attribute, we talked about an adjective. Method is a verb. Variable is a named location in memory that has a type. Name and type, very important for a variable. A method signature has to be unique, and within the open and closed curly, we have the logic that will occur within the method. Okay, we know we have different types of data, complex types like strings, text fields where we can enter data and label, and we know we have primitive types that are very close to those zeros and ones: int, float, double boolean. Okay, syntax, we know Pascal case for class names, camel case for variable and method names. Okay, and we know some rules around attribute and variable syntax. So we'll leave it off there. We'll pick up more with an example program in our next presentation. Thank you.